Hello class, it's Mr. Smith. I'm just sitting here in my table getting ready to go. So to begin, I hope that you did this section right in here yourselves out of your textbook, and you will not need me to redo it. So to begin with, yesterday in class we reviewed this equation right here for determining the length of a line segment. So we can use this formula to build the equation of a circle centered at the origin, or 0, 0, by substituting 0, 0 for x1 and y1. So I'm going to go ahead and do that. And if I put in 0 in here, that's not bad. Kind of looks like a letter U. Sorry, my pen's not amazing. What you end up with after this is that you end up with D equals the root of, I'm going to try to make that bracket a little bit better. I'm going to erase it. I don't like it at all. You end up with D equals just x now. We don't need the 2. And this x is going to be squared. That is just terrible. Plus y squared. And I'm sorry if that was about the wonkiest plus sign ever on the face of this planet. I'll just improve it. There we go. So that's not a bad start. I'm going to flip to my next page and you guys can kind of just keep going. So we know that the distance from the center of the circle to its circumference is known as the radius. So we replace the D with an R, which gives us now R equals the root of x squared plus y squared. Sorry if my writing looks like a 2-year-old's. So finally we need to get rid of the radical sign, and if you're a little bit concerned about what I mean when I'm talking about the radical sign, it's that thing right there. It's I also kind of gave you a little hint what the radical sign is by saying right here that's what it is, but that's the radical sign right there. Realizing why my penmanship's off, my alignment is totally off. So we've got R equals the root of x squared plus y squared. And to get rid of our radical sign, we have to square this side, and we'll just square that side. So now we know R squared equals x squared plus y squared. That right there is the equation of a circle. I'm trying to make my letters look like actual letters. C-I-R-C-L-E. Centered at 0, 0. I'm going to take a second and draw a couple stars. Make sure you know that that is extra, ultra, super important. I'm going to flip to the next slide. Okay, so now I need to figure out the coordinates of the center of the circle. And if you look back to the front of your note, you'll know that the example I'm doing is for a circle centered at the origin, or 0, 0. Now when I look at our equation up here, I can see that we have 16 right here. The radius of that is going to be the root of 16. So I know that the R part of the formula is right here, and that's what R squared equals. So I know that R squared equals 16, therefore R equals 4. And I hope the math of how I did that is pretty obvious. I took the root of R squared and I took the root of 16 to get 4. I hope that you remember from grade 9 that diameter equals 2 times the radius. So therefore, diameter equals 2 times 4, which equals 8. And all of these examples, so all of these examples here correspond with this equation right there. Sorry if my dishwasher's loud. So next is going to be a little tricky, the x-intercept. So imagine we've got a circle, and in our circle it's going to have an x-intercept of, I'm just trying to make sure I do this right. It's going to have one x-intercept of 4, 0. And it's going to have another x-intercept at negative 4, 0. And hopefully that makes sense. Y in a couple seconds. It's going to have a y-intercept at 0, 4. And 0, negative 4. And our graph of the circle. Here we go. Try my best. I'm going to have super shaky hands on this. So there's one dot right, there's 1 point right there. There's 1 point right there at 4. There's another point there at negative 4. And there's our other one. So here we go. So there's our 4 points. Here we go. Circle time. Not terrible. And I could be even fancier if I wanted to. I could try to take a fancy circle. Let's see if I can do this. Here we go. Oh, not bad. It's not a perfect circle though. If I really wanted to, that's not terrible actually. Pretty proud of myself. Let's see if I can make it really. Anyways, you get the idea. There's my hand drawn, and there's probably a little bit closer to reality. Right. So with this example, it's a little bit different because we have to determine different equations for A, B, C, D, and E. So we're talking about 5 different circles, not all the same circle like the last one, but 5 different ones. So our first one has the radius being 12. So if you know that the radius is 12, you know that if r equals 12, therefore 12 squared equals a squared plus b, not a squared and plus b squared, let me erase that. Sorry about that. Equals x squared plus y squared, and that would be our equation for A. So that circle right there, there's our equation. I'm going to switch colors just so it's clear. So for our second question, diameter is 2 units. So if diameter equals double the radius, we've got 10 equals 2 times r. So to figure out the radius here, we're going to divide by 2, divide by 2. So r equals 5. Is this good with everybody? And now I'm going to do it like I did before. The final step is going to be 5 squared equals x squared plus y squared. And above, I forgot to finish it off. My final answer for B should be 25 equals x squared plus y squared. And above, I forgot to finish that off. It should be 144 equals x squared. So if my x looks kind of wonky, plus y squared. I ran out of room. Can't draw my 2. Oh, there it did. It's supposed to be above the y. So the next one involves a little bit of visualization. If one of the y-intercepts is 9, think about it this way. If you've got your circle and it's centered on the origin, each one of these points is going to be its radius as well. So if one of the y-intercepts is 9, so from here to there is 9 units, that's also its radius. We know that r equals 9, and so the equation of this circle would be 9 squared equals x squared plus y squared, and to finish that off, it would be 81 equals x squared plus y squared. So if my 8 looks kind of wonky, this pen just is not cooperating. That's better. So this last one's going to be a little tricky. The point on the circle is 2, 5. Don't forget that that point is also in x, comma, y. So what I would do if it was me is I would know that the equation of the circle is r squared equals x squared. So I then take this value right here. I take that value of 2. So I say r squared equals 2 squared plus, and I take the 5 value and I'll kind of, so I got the 2 right here, and I got the 5 right there. So I know r squared equals 2 squared plus 5 squared. So the next thing I'm going to do is I'm going to say that that equals, I'm sorry, I'm going to run out of room here, that's 4 plus 25. And then 4 plus 25 equals 29. And I believe right there, that's what our r squared value is. So what we can do now is we can just say that 29 equals x plus y, squared. And there's our equation there. It's not the radius itself is going to be a decimal, but the equation is this. And just to be very clear, you can also rewrite these as x squared plus y squared equals 29, and that's the same as well. So finally, it's really a check kind of question. So it's saying, well, does the point 2, 3 lie on x squared plus y squared equals 16? You remember last unit doing the right side equals left side check? So you can say left side equals 2 squared plus 3 squared. That's 4 plus 9, 13. And right side equals 16. And I hope you know where I got all those numbers from. So since LS does not equal right side, therefore the point two, 3 does not lie on the circle.